Now that we're finished all of the different components of the stoichiometry unit, I thought we should maybe take a minute to look at one last example where we put absolutely everything together, including a limiting reactant situation. So here's the question that I'm going to suggest that we work through. It says, the reaction between aluminum metal and hydrochloric acid produces 350 kilojoules of energy per mole of hydrogen gas that is produced. How much energy would be produced if 34.5 grams of aluminum is reacted with 95.7 grams of hydrochloric acid? There's quite a bit of information to digest there. If you want to pause the video and read through the question one more time before going on to the answer, please feel free. I'm going to continue though. So this is a stoichiometry calculation. The first step in every single stoichiometry calculation is to write yourself a balanced equation. In this particular case, you are told that the reactants are aluminum metal, which is a solid, and hydrochloric acid, which would be aqueous. Those two things are going to go together to create some products. If you look at the type of reactants you have, very clearly you have an element and a compound, so this is a single replacement reaction. The aluminum is going to kick the hydrogen out of the compound, resulting in hydrogen gas being produced and the combination of aluminum and chlorine. The wording of the question also indicates that this is an exothermic reaction. It says that energy is produced, so you should include some energy on the product side. The reaction is not balanced as it is. If you were going to balance for matter, you would need to include coefficients of 2, 6, 3, and 2. So once you get to that point, you would look back up into the question and it says that the reaction produces 350 kilojoules of energy per mole of hydrogen gas, and hydrogen gas has a coefficient of 3. So if you wanted to include a numerical value for energy in your reaction, you would need to take 3 moles times 350 kilojoules per mole, resulting in 1050 kilojoules of energy on the product side of your reaction equation. So that's the reaction that we're going to be dealing with. Step 2 is going to be to determine which reactant is the limiting reactant. That will require us to go through a series of steps, the first of which is turning the grams that we're given for aluminum and for hydrochloric acid into moles. In both cases, we're going to divide by the molar mass of the substance. That alone is not enough to tell us which one's the limiting reactant. We're also going to have to then factor in the coefficients that each of those substances have in the balanced equation. Aluminum, of course, having a 2 and hydrochloric acid having a 6. Once you take all of that together, you find out that you have enough aluminum to go through the reaction a little more than 0.6 times, and you have enough hydrochloric acid to go through the reaction a little more than 0.4 times. Of course, the 0.4 times that you can get through with the hydrochloric acid is less than the 0.6 times you can get through with the aluminum. As a result, the hydrochloric acid is the limiting reactant. Step 3. Now that we've figured out which one is the limiting reactant, we can actually answer the question. That's going to need us to take the reaction that we figured out, the amount of the limiting reactant that we've been given in the question, and what we're looking for is how many kilojoules of energy will be produced. In order to do that calculation, we're going to have to use the fact that 6 moles of hydrochloric acid need to react in order to produce 1050 kilojoules of energy. So if we can take our 95.7 grams of HCl and once again convert that to moles, we'll then be able to multiply that by a stoichiometric fraction that would have energy on the top and moles of HCl on the bottom. And as you can see, that would then result with us having 459 kilojoules of energy produced. And there you have it. One question that involves pretty much everything that we did in the entire unit.